Hello everyone, this is Sam from HiPy. Today we're going to be looking at some k-means clustering algorithms. Don't worry, I'm going to be doing some coding in this one. I'm just going to start off in the actual guide here because the thing that we need to know is the actual algorithm first, and it's much easier for me to go through these pictures and show you what it means and kind of explain it than to try and explain it using Microsoft Paint or some other garbage program. So the k-means clustering algorithm is a unsupervised algorithm, so it takes unlabeled, so we don't have any kind of data information about it in, and then it just categorizes it straight away into groups or clusters. So we can see here the end result that we get is three nice clusters because we've set our kind of parameter to 3 here, where we have and we also have spaces here, but we'll look at that later, in which a new point would come in and it would be a member of that cluster. So how does it work? So the first thing that happens is we choose 3 random points in our data set. They don't even have to be in our data set technically, but the way that the function will work in scikit-learn is it'll choose 3 different points in our data set. Or sorry, it'll choose k different points in our data set. Here we're choosing k equals 3. So just to make sure that we understand that, we have the reason it's called k-means clustering is because we have to choose a parameter k, which is how many clusters we're sorting into. So here k equals 3, and we have 3 randomly chosen means, and then it associates each of these grey points, so each of our data points, with the closest mean to it geometrically. So in a 2D example, this is just quite easy. It's just the 2-dimensional distance. In the 3-dimensional sense, it'll take the 3-dimensional distance and so on and so on, and we can extend that to higher dimensions. So then it'll move the mean to the center point of all of these kind of points that were associated with it. So, for example, this red one only has 1 point associated with it. So the center of this 1 point is just going to be that 1 point. So it moves that center to that 1 point here. And then the center of these 3 points is going to be around about here. So that moves here. And then the blue moves as well. And then we keep on repeating these 2 steps here until we have an equilibrium when no more changes occur. So here we can see at the end we have the red thing here, the green cluster here, and the blue cluster here. So the only kind of downside I'm going to go into right now is how do we choose k? The main problem with the k-means algorithm is we don't really know what k is, and we don't really know, unless we have some kind of context clue, we don't really know what k should be. And there's a very kind of like kind of hacky way that we can do this, and we'll see this later on in the guide. I won't really cover it in this video because I don't really have time, but it's called the elbow method, in which we have the kind of the mean errors here, and we'll see that at some point, which is k equals 4 for this one, the errors just level off and they don't really stop improving, and that's kind of what we want to aim for. We want to hit the minimum possible k where our errors stop improving. So at this point we're not really seeing any improvement, so if we took k equals 5, there's no real improvement. And we want to hit that point at k equals 4 in this example, where we don't really get much improvement in our model. So we're going to look at how to implement this in a very simple sense, and then I'll kind of very quickly explain how to apply it to different situations. So here are the model. Here are the functions and the libraries we want to import. We have numpy as np, sklearn.cluster as k. We want to import k-means from sklearn.cluster. We're going to fake some data here, so we're going to get the make blobs from sklearn dataset, and then we're going to import our good friends matplotlib and pandas under their respective names. So then I'm going to scroll down a little bit here. We are going to get some data. We're going to take some data, and we're going to use the make blobs function. We're going to take n samples, which we're going to take 400 samples. We're going to take 3 centers here. Why not? We'll take 3 centers. And it might look a bit weird that I'm going to do this, but I have to index this as a 0. Make blobs will output a tuple or a list of well, they're not the same thing, but it's one or the other, to be honest. And I think it's a tuple. It'll output a load of different information, and the thing in the first index is the data we want, and then everything else is just a load of information about our data. So we only want the first index here because we just want the data, and we are going to print the data.head. And we're just going to do this, and that should give us numpy. Okay, that's because it's not a pandas, is it? It's a list, so we're going to just do that. That's the equivalent of doing a head. So we can see here we have a load of 2-dimensional points that we are going to look at, and what we can actually do to plot these straight away is I'm going to skip a step that's not in the guide here because I'll explain it here. We can just scatter these 2 points, well, all of these points in a scatter graph. So the way to do this quickly is that you might notice here that our two-dimensional kind of array has kind of 2 points in every kind of data point. So we have an x coordinate and a y coordinate. But the problem is that we need a way to unpack this so that we get all the x coordinates in a list and all the y coordinates in a list. And NumPy comes with a really nice way of doing this in its slicing. So if we do data and then we index as normal, we do colon, comma, 0, and we do exactly the same thing but colon, comma, 1, we will actually get the graph that we want. And the reason why this happens is because it's taking every single kind of actual index, and then it's just taking the 0. So we will see in a normal kind of indexing way, we might see data 0 will take the first list, and then data 1 will take the second list. What data colon does in NumPy is it just takes all the lists, and then when we comma, it then goes to the next dimension. So we go in a list, and then now we'll be looking at every kind of individual list. So 0 will take the first of every list, and 1 will take the second of every list. So if that's a little bit confusing, don't worry. It's a trick that I'm going to use over and over again because we're working with NumPy arrays with scikit-learn. But it is quite nice to learn, but we're not going to be using any other tricks like that. So as long as you understand kind of the basics of how it works, you'll be fine. So we're going to do plt.show, and we have a little bit of a problem here in that we only have 2 clear clusters. So I'm actually just going to run my data again, and that's just 1 cluster, and I'm going to run my data again until we get 3 clusters, just for the sake of this example. I know that's cheating, but we are just going to do it, just so that this example is a little bit clearer. I recommend that you do the same thing when you're learning your first thing, and I recommend you plot it when you're doing your first thing, because we're randomly generating points and blobs. Sometimes these blobs will overlap, and we'll get kind of a very sad situation where we're not, our model isn't going to really run correctly, and we're not going to see some nice results. So we're not going to we're not going to look at the kind of data anymore. We're going to treat the data as just a completely new to us data set which we haven't seen before, so this is going to take a little bit of imagination, but we're going to look at how the model works. So we're going to go through this quite quickly. The model is we're going to build the model straight away. So this is going to use the k-means function. So k-means, we're going to take n clusters equal 3, because we know this already, or we're going to guess it, I guess, and then we're going to go dot fit and then data. So what we can do is we can split this into 2 things if we're uncomfortable about this. We can just go model equals k-means n clusters equals 3, and then we can just go models.fit. But here I'm skipping a step and just doing it straight away. And then what we're going to do after that is we are going to look at what some of the attributes of models. We're going to say centers equals model.cluster_centers. Cluster underscore centers underscore. That might look a bit weird, but that's just how the formatting is. We have labels equals model dot labels, and then that's an underscore after that as well. And then we're going to very quickly plot all of these together. So plt.scatter, we have data 1 and data our x values and our y values, which I'm just going to copy here, which is a little bit naughty that I've done that, but hey ho. We are also going to do plt.scatter centers. Look at centers colon 0 centers colon 1, and we're going to put these as C black. And we're also going to put the actual points with a color depending on what label they're in. So label is a big NumPy array with like 0, 1s and 2s, which we're then going to use to label our different colors. And with everything, hopefully we have label is not defined because it's labels, not label. There we go. And then we're actually going to show the plot. That's good. We're going to see that we have 3 different clusters here, and they're all sorted. So that might not be impressive to you straight away, but we're going to use the algorithm then to apply it to 2 different situations, which are mini projects. One is that we have a lot of different customer information which we want to cluster, so we can see with a new customer where they'll kind of fall into. And you're going to need the prediction function for that, which is just model.predict. And then we're going to do some image quantization, so that's a little bit tougher and a little bit of more of a project, but unfortunately we don't have time to cover that in this one. So next time we'll be looking at a different machine learning algorithm, so I'll see you then.